Okay, hello everyone. I welcome to all in our lecture series on laser physics. In this lecture series, we are discussing these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. In our last 5 classes, we discussed these 5 topics. In this class, we are going to discuss Einstein's A and B coefficients and their relations and physical significance. Okay, so let us start. So these topics already we have been discussed in our last 5 classes. Okay, last class I discussed the difference between light by spontaneous and stimulated emission and 2 numericals and application also. This class we are going to discuss Einstein's A and B coefficients, their relations and physical significance. Most important topic itself. If this topic will be asked in your exam, it will ask for 5 to 6 mark. Okay, so carefully watch and prepare for your exam. To understand about relations and physical significance of A and B or Einstein coefficients, consider a two-level system. Lower level have energy E1 and upper level energy E2. Same thing I have been written. Consider two energy level system. E1 and E2 are the energies of atom, molecule or electron at state 1 and 2 respectively. Let at particular instant N1 and N2 are the number of atoms or molecules or electrons per unit volume corresponds to the states E1 and E2 respectively, or you can say N1 and N2 are the concentration, atomic or molecular concentration for E1 and E2, lower energy level and upper energy level respectively. Okay, let U mu is the energy density per unit frequency range of a pumping system. That pumping system may be optical, electrical or chemical, and we know that the pumping system is a energy provider to the laser system from the outside. Okay, so here U mu represents the energy density per unit frequency range of the pumping system. You just remember U mu represents the energy density of pumping system. Let us energy difference between E1 and E2 equal to h mu. Hence, an atom or molecule or electron will be excited to E2 from ground state E1 when it will gain exactly h mu amount of energy. That is called as the stimulated absorption, whatever already we have been discussed in our previous class. So, the atoms, molecules, see this black circular object represents either atom or molecule or electron. So from the ground state or from state having the energy E1 to E2, it will excite if the atom or molecule or electron will absorb h mu amount of energy or energy difference between upper and lower energy level. Then it will move or excite from this E1 energy level to E2 energy level. That is called as your stimulated absorption. Stimulated absorption, why? Because these atoms, these ground state atoms or molecules is stimulated by a pumping source or outside source. Then it is excited to the upper energy level by absorbing h mu amount of energy. That's it. Okay, from the figure it can be imagined that the rate of stimulated absorption, here rate of stimulated absorption, which is represented as gamma STA. Here STA is in the subscript like this, gamma STA for stimulated absorption. What is the meaning of that? Number of atoms or molecules or electrons in E1 level absorb energy h mu stimulatedly per unit volume per unit time. Okay, so this is this gamma STA represents the rate of stimulated absorption. That means the number of atoms, you can say number of atoms in this energy level, ground state energy level, absorb energy h mu stimulatedly means outside energy provider per unit volume per unit time is proportional to number density and energy density. Here number density means number of atoms or molecules present per unit volume in ground state or in state E1, and this one energy density of the provider, outside provider, that may be with the help of light, here with the light or optical, electrical or chemical, whatever. That implies gamma STA will be equal to one constant. Here proportional to means if I'm going to do equal, if I'm going to put equal sign, we have to put a constant. This constant represented by B12. Here 1 2 means it transit from 1 to 2, or excited from 1 to 2, or you can say moved from one state to 2 state. And B letter represents the stimulated. So here stimulated absorption, here B12 represents the coefficient of this one, coefficient of stimulated absorption. B12 is a constant of proportionality called Einstein's coefficient of stimulated absorption, or some books written as probability of stimulated absorption, PSA. Okay, so here B12 is your coefficient of stimulated absorption. Here 1 2 represent 1 2 means 1 to 2. It moved, atom or molecule moved from 1 to 2. Okay, if it will written as 2 to 2 1, that means it moved from 2 to 1. Okay. Now rate of spontaneous emission. Here we discussed stimulated absorption. That means the ground state atoms and molecules gained energy h mu from outside pumping device and moved to upper level, which is called as the stimulated absorption. Now these atoms which are excited to higher energy level, these atoms can transit from higher to lower by two processes. It can be transit by spontaneous emission, it can be transit by stimulated emission. Now we are going to find out what will be the rate of spontaneous emission and what will be the value of rate of stimulated emission. Here rate of spontaneous emission means what? Number of atoms or molecules or electrons in the energy state E2 or in the upper energy level emitted energy, how much? H mu, spontaneously or naturally, per unit volume, per unit time. That is so called your rate of spontaneous emission, right? So rate of spontaneous emission here represented as gamma SPE, which is proportional to only N2. Okay, so transition from E2 to E1 spontaneously depends only upon the atomic or molecular concentration of the upper energy level. This transition not depends upon the U mu, energy density of the outside provider or pumping system. Okay, so gamma SPE or rate of spontaneous emission is equal to some constant. Here constant written as T21 N2. Here proportional to sign, if I am going to remove, then a constant will be written. The constant is your T21. T21 represents the Einstein's coefficient of spontaneous emission or probability of spontaneous emission. So here spontaneous emission, the probability of spontaneous emission or Einstein coefficient of spontaneous emission can be two types. It can be, it is the sum of the two types represented as A21 plus S21. What is the meaning of A21? See, if the transition, if the spontaneous transition is a radiative transition, then it will be represented by A21. If spontaneous emission is non-radiative transition, it will be represented by S21. If we have both spontaneous, both radiative and non-radiative transition, then Einstein coefficient of spontaneous emission represented by sum of the radiative and non-radiative transition. If only radiative transition we have through the spontaneous emission, then T2 is written as A21. If only non-radiative transition, then T21 represented by S21. Remember this one, which is most important, because whenever we are going to discuss rate equation for 2 level, 3 level and 4 level laser system, at that time these two symbols are required. Okay. Now, rate of stimulated emission represented as gamma STE. Here ST is in the subscript. Okay. What is the meaning of rate of stimulated emission? The number of atoms or molecules in E2 energy level emitted energy h mu stimulatedly or artificially per unit volume per unit time, and which is this gamma STE, stimulated rate of stimulated emission, obviously is depends upon N2, number density of E2 level, and U mu. Here stimulatedly the transition is going to be happen. Stimulatedly, how it will happen? When the external energy will stimulate these atoms. So external energy means outside energy provided or optical pumping system energy we are going to provide. That optical system energy or outside energy will stimulate these atoms or molecules, then it will transit to ground state. That is called as your stimulated emission. So obviously this stimulated emission or rate of stimulated emission is proportional to N2 and U mu. N2 is the number density of E2 level. U mu is the energy density of pumping system. Okay. So if I am going to remove this proportionality sign, we have to put a constant, that is your B21. So stimulated means it is represented by B. Here stimulated absorption represented by B1 to 2. Here stimulated emission represented by B21. Here 21 means transition happens from 2 to 1. Right. Let this is your equation number 3. Here B21 is a constant of proportionality called Einstein's coefficient of stimulated emission or probability of stimulated emission, which is represented as PSTE. Here also for spontaneous emission represented by PSPE. Okay. See, whatever the note I written, this is enough for your exam. No need to write extra. This much is enough for your exam. Okay. Now, so here we found the expression of stimulated absorption, that is your gamma STA B1 to N1 mu U mu, U function of mu. Okay, U function of mu. Let this is your equation number 1. In equation number 2 represents the rate of spontaneous emission, which is equal to T21 into N2. T21 is a sum of A21 plus S21, and rate of stimulated emission gamma STE we found this much in your equation number 3, represented by equation number 3. Okay, at thermal equilibrium, rate of absorption is equal to rate of emission. That is called thermal equilibrium. Thermal equilibrium means the rate of absorption should be equal to rate of emission. So rate of absorption is nothing but stimulated absorption. So gamma STA equal to, this is gamma SPE, spontaneous emission, rate of spontaneous emission plus rate of stimulated emission. Here I written the values. Gamma STA value is your B1 to N1 U mu. Okay, and here gamma SPE is nothing but your T21 N2, and gamma STE is nothing but B21 N2 U mu. Right, is equal to, here T21 is can be written as A21 plus S21 N2 plus this factor. Let this is your equation number 4, right? Take this one to the left side, this side. So that implies B12N1 minus B21N2 u mu equal to A21N2. Here we considered, or it has to remember that in two level system T221 is purely radiative transition. Purely radiative means A21 will appear in this expression. H21 is the non-radiative transition, has to removed. So here for this case we have to, for two level laser system, this value is nothing but only A21 radiative transition factor we have to write A21. So from this expression we can write u mu equal to A21 into N2 divided by this factor. Okay, this factor. Okay, that implies u mu. Here you can see u mu. We written we found this one. Same thing I written once again. That implies u mu equal to, here I divided N2 with numerator and denominator. So here A21 into N2 by N2 equal to 1. Equal to 1 I not written over here. Then B21 divide B21 N1 by N2 minus B12 N1 by N2, okay, minus B21 by N2. N2 got cancel, so only B21. That implies u mu is equal to, here you can see this one written as like this. Again B21 divided with numerator and denominator. If I will divide with numerator, then it will be A21 by B21. Then I have to divide with this factor and I have to divide with this factor. If I will divide with this factor, the value will be 1, and B12 divided with this factor written here. Okay. According to Boltzmann distribution law, the number of atoms in energy level U1 and U2 in thermal equilibrium at temperature T is nothing but this one. You just remember, already you have been studied in your statistical physics or solid state physics somewhere. N1, this N1 is nothing but, according to Boltzmann distribution, N0 e to the power minus U1 by kT at a particular temperature. N2, concentration in level 2 equal to N0. N0 is the total number of atoms or molecules or particles. You can say here N0 is nothing but N1 plus N2. I not written over here. I will write here N0 equal to N1 plus N2. Okay, so N2 is the concentration of E2 level equal to N0 e to the minus E2 by kT. You just remember these two expressions. With the help of these two expressions, you can solve many numericals in your exam itself. So here N2 by N1, if I am going to divide these two equations, we can found this one, e to the power minus E2 minus U1 by kT, or E2 minus U1 written as h mu, so e to the power minus h mu by kT. So that implies N1 by N2. Here N2 by N1 we found this one. So if I am going to just reverse, or we are going to take the reciprocal of this equation, N1 by N2 will be e to the power h mu by kT. Let this is your equation number 6. Now put this value in equation number 5. What we can get? U mu equal to A2 by A21 by B21, already it is in the numerator. B12 by B21, it is there. N2 by N1, instead of N2 by N1, here I substituted the value, this one, e to the power h mu by kT minus 1, right? Now consider Planck's radiation formula. This is the Planck's radiation formula. The energy density is equal to 8 pi h mu by cq into 1 by e to the power h mu by kT minus 1. Let this is your equation number 8. Now compare equation number 7 and 8. Equation number 7 represents the energy density. Equation number 8 also. If I am going to compare, what I can found here, A21 by B21 numerator part then we can found is equal to this one, this much, 8 pi h mu by cq, right? And here the coefficient of e to the power h mu by kt is your b12 by b21. So here the coefficient is how much? Only 1. So b12 by b21 equal to 1. Okay. So by comparing the numerator part, equation number 7 and 8, you can see a12 by b21, a12 by b21 value is your 8 pi h mu q by cq. So here 8 pi h c, these terms are constant. 8 pi h c constants. Mu is the frequency of energy provider or pumping system, you can say. Okay. So here a21 by b21 is going to proportional to mu q. Let this is your equation number 10. Likewise, by comparing the coefficient of this one, e to the h mu by kt, we can found b12 by b21 equal to 1 or b12 equal to b21. Let this is your equation number 11. Right? Right. Equation number, if I am going to consider equations 10 and 11 represents the relation between Einstein coefficient. So equation number 10 and 11 represents the relation between Einstein's coefficient. Okay, just remember for two level laser system and non-degenerate case. So here we consider strictly two level laser system, and the energy here, upper energy level is your E2 and lower energy level has energy E1, and it is non-degenerate. Non-degenerate, this is the single state and this is the single state itself. So if I am going to consider degenerate case, which is not in your syllabus, that means suppose I am going to consider upper energy level is not only one state, it is degenerated by two state, then this expression will somewhat will be modified. But here in our syllabus you have non-degenerate case. So for this non-degenerate two level laser system, this is the relation between Einstein coefficients. Now physical significance of A and B. We are going to discuss physical significance of A and B. Now for that, consider equation number 10, this one. The probability of spontaneous emission dominates over probability of stimulated emission more and more with increase in energy difference between two states. So here this factor represents the ratio between spontaneous emission over stimulated emission. So this is the two level laser system. So emission can happen by two process. One is your spontaneously, one is your stimulatedly. So spontaneous process can be dominate if this energy difference will be more and more. So here energy difference is how much? E2 minus E1 equal to h mu, right? So h is the constant. So here E2 minus E1 is simply proportional to its mu q. So if this energy difference, if I am going to increase mu, that means what? I have to increase this difference. Then it will be E2 minus E1 will increase. So if I am going to increase the difference between upper energy level E2 and E1, then what we are going to found? We can found spontaneous emission will dominate more and more upon stimulated emission. So same thing it has been written. The spontaneous emission dominate over the probability of, or the probability of spontaneous emission. This is the probability of spontaneous emission, or what? Or that is called as your coefficient, Einstein coefficient of stimulated emission and spontaneous emission. So probability of spontaneous emission dominates over probability of stimulated emission more and more with increase in energy difference between two states, which is most important result in this discussion. Okay. Now consider equation number 11 here. Stimulated emission. Here we have for two level laser system, this is the higher energy level, this is the lower energy level. Two stimulated process we have. One is your stimulated absorption and another is your stimulated emission. So this is coefficient is represented by B12 and this is represented B21. So for a two level energy level laser system, we can found this B12 equal to B21, or we can say probability of stimulated absorption, this one B12 is equal to probability of stimulated emission. This is also important result of this discussion that you have to remember, but I told that this is only for applicable for non-degenerate condition. If suppose upper energy level degenerated with another two energy level, then this relation will be modified somewhat. Okay, but as per your syllabus, this much is your non-degenerate case you have in your syllabus, so you just refer this note or discussion. Okay. Okay, now if I'm going to consider rate of spontaneous emission and rate of stimulated emission, a ratio between them, if I'm going to consider ratio between spontaneous emission to stimulated emission, then what we are going to get? Here you can see rate of spontaneous emission value is how much? Here rate of spontaneous emission value this one. If I'm going to consider two level laser system, so it will be A21N2, right? A21N2 divided by and stimulated emission B21N2 u mu, that I have been written over here. So ratio between spontaneous emission by stimulated emission equal to this by this, right? Okay, here A21 by B21 value is how much? A21 by B21 value is this much. So from equation number 9 we found A21 by B21. I just substituted over here 8 pi h mu q by cq by here n2 got cancel. U mu value is how much? U mu value is this much, already we discussed over here. Okay, so this factor got cancelled and we found the ratio between rate of spontaneous emission to stimulated emission is equal to this one. This factor will be moved to the numerator. It will be e to the power h mu by kt minus 1, or instead of h mu we can write e2 minus e1 by kt minus 1. So here you can see this ratio is proportional to e2 minus e1, or difference between the two energy level. So if the difference between the two energy level, this one, will increase, then this spontaneous emission, rate of spontaneous emission, this one will more and more dominate over stimulated emission, and we are not going to get laser action, because we can get the laser action if stimulated emission will dominate over spontaneous emission. But if spontaneous emission will dominate over stimulated emission, then we could not found the laser action. So from equation number 12 it is concluded that if the energy difference will increases, then rate of spontaneous emission dominates over rate of stimulated emission. Same thing I have written. From equation number 12 it can be found that rate of spontaneous emission dominate over rate of stimulated emission more and more with increase in energy difference between two states, right? Same thing here. We discussed the same thing. From this expression, probability of spontaneous emission dominate over probability of stimulated emission if the energy difference between the two level will increase. Okay. Now from equation number 12, another interesting result we can also observe. What here? If this factor is greater than 1, that means what? That means this value is large and this value is less. This value is large means rate of spontaneous emission dominate over rate of stimulated emission. That means if this ratio we can get greater than 1, then no laser action condition we can found. But if this ratio less than 1, that is the laser action condition. Rate of stimulated emission dominate over rate of spontaneous emission, or the laser action condition we can found. Okay, so these are the results what we have derived for by considering a two-level laser system, and these are the physical significance. This one and this one, what we discussed with the help of equation number 10 and 11. Okay. Okay, so here I am going to stop this lecture. Next lecture we are going to discuss unit and dimension of Einstein's coefficient A and B. Okay, thank you so much for watching this video. Thank you.